Right, hello and welcome to this next tutorial. Well, it's not a tutorial, it's the fourth question on the AQA AS physics course for June 2010. Let me get it up there. Right, so you can see that just about. So, just get the camera ready. There you go. So, this question says it's a trampoline, not meant to be a very bad trampoline, but still, camera likes to go down a bit there, just so you don't get to see the joy. Let me just sort this out. Oops, sorry. Right, there you are. So it's meant to be a trampoline, stand out of the way back here. So it's asking us, calculate the distance or the increase in gravitational potential energy between position A, which looks like she's sort of falling in to the trampoline there, and the height, which you can just see a microscopic thing at the top of the whiteboard. It says 4.2 meters between A and B. It says calculate gravitational potential energy. Now it says mass is 55 kilograms. Now for GPA, as I've labelled here, it's mg times delta h. Now m stands for the mass, g times for the acceleration due to gravity, which is 5.81, and the h, delta h, is changing height. So the changing height is 4.2 meters. This is because, well, actually, if you don't understand why GPA is that, go into our video of working power. And you can understand why that is. So put it into our formula for GPA equals 55 kilograms times 9.8 times delta H, which is 4.2 meters. Now for the more eagle-eyed viewer, I missed out the 0.01. So this means that GPA is equal, it's in our calculator. I'm actually bring the calculator up, it's crazy enough so you can actually see it. So we've got our calculator there. We do, see it? 55. Oh, you can't see that real actually. So yeah. So you can do it this way. 55 times, that's the weight, 55 kilograms times 9.81 times the changing height, which is, oh sorry, I just pointed the shot to see that, 4.2 meters, and that comes out on mine as, I don't know if you can see that well, 2,266.11 meters, joules even. So round it up to 2,267 joules. Hopefully you've understood where we've got that from. That's annoying me. Nice calculator. Camera even. Trying to get it perfect, but there's only physics you can do. For your camcorder starts to die of pain and exhaustion. The next question, 4B, is slightly different. It says the gymnast descends from position B, which is the height, which is what we calculated, and regains contact with the trampoline when it is in an unstretched position, which is that bit there. The centre of mass is 3.2 metres below its position at B. So between B and the trampoline it's 3.2 metres. Between B and A is 4.2. And right, so this is the correct way of doing 4B. So 4B, it's asking us to find kinetic energy, which is 3.2 over 4.2 times 2 to 6, 4, and that gives you 1,700 joules. 1,700, yep. That's the answer to 4B. Oh yeah, right, I know what I did. What I did before, if you were wondering, I assumed it was the whole, we were only in 3.2 metres. So, the way we could have worked that out, that make make sure before I do this right. 55, 9.8 times 3.2. Yeah, right. So if you wondered where I got another way of doing 1700 joules, if you didn't quite get it, you could do mg times delta H equals GPE. Mg times delta H, if you do it this way, is 55 times 9.8 times 3.2 equals, equals kinetic energy, that one. Equals KE. That's not how you work out KE, that's just because we assume no force is lost, so it gains what it loses in terms of gravitational to kinetic, and obviously the other way around as well. And that comes to about 1,700, what was it? 24.8 joules. And obviously you can round that down, which I have done there, to 1,700 joules. But essentially, we get the same answer. So that's one way of doing it. If you didn't get the first way, which I didn't, because I just looked at the mark scheme to see which way they'd done it, I got exactly the same answer. And to me, finding out the way I did it seems definitely a lot simpler. I'm just going to make sure you can see it, because sometimes I ramble on far too much. So you see there, oh damn it, I put mg times delta H equals KE, worked out mg times delta H, and that is the same as the other one. Right. So that was 4B, essentially. Right, hopefully you've understood where we've got that from. We're going to go into our next topic, next bit. It says calculate the velocity, is it? Before she reaches the unstretched trampoline. So, we know K equals, so this is 4C now, 4B part 2 even. Ke equals half of mv squared. So we know the kinetic energy is 2.48 equals half times 55 kilograms times v squared. We substitute this round. I'm not doing any calculations yet. Over half times 55 kilograms equals v squared. Square root both sides, so we square root that. 1724.8 over half times 55 equals v. So therefore v equals 7.9 meters per second. That was quite a lot of writing I had to do there. Hopefully it's helped you to understand where we've got that from. Okay, so we'll just see if you can see that. I'm not sure if you can, to be honest. A lot of writing there. So I'll just zoom in so you can see it. So you see there we've got Ke equals half mv squared. We got Ke from the equation up here, working out mg times delta H. We said that the fact that the energy gained is equal to energy lost in terms of gained kinetic energy from gravitational. So gravitational loses it as it falls, the other way around if it's gaining height. So we said that equal, so you can just put the energy for kinetic, GPA into kinetic, put that as the answer. We know the mass, we don't know the velocity, put that, substitute in, square root it, and that gives us V, 7.9 meters per second, to two significant figures. Hopefully that's sort of encased your understanding a bit more there, and you've had some physics fun in the process. Right, so that's 4B part 2. The next part, it says on figure 4, which is that one, draw the force exerted by the gymnast when she's positioned at A. Now this says 1 arrow vertically upward pointing starts on the soles of her feet. So all we have to do is draw a line from the soles of her feet upwards vertically. Obviously that's not a very good drawing, but you know, mind stuff you if you don't like it. So it says 4D. As she accelerates upwards again from position A, which is the base, it says she is in contact with the trampoline for a further 0.26 seconds. Calculate the average acceleration she would experience while in contact with the trampoline. So we know her velocity is 7.9 seconds, so V equals U plus AT. Rearrange it to get A, so A equals delta V over delta T. So A equals 7.9. She doesn't start at velocity, she starts at 0. 7.290 over 0.26. Therefore A is equal to 30 meters per second. And that's your acceleration answer there. Hopefully you've got that. That's the end of question. Oh, is it not? I thought it was the end of question 4. Alright, well that's fun. I'm just going to rub it off now, so just keep moving. Right, so this is the big question on, sorry. There we are. This is the big question on question 4. Well, it's a big question on the exam, actually. It entails the big written community of qualification, whatever rubbish it comes up with. That's a good example, because I didn't use it just now. So it's just, to get all this rubbish off board. Probably hard enough of watching this, but we're nearly there. So, just going to get a drink just after log on. Can't deal with that, that's the physics world for you, it destroys you inside. Right, sorry that. That's some good juice, that. Tasty juice. Unfortunately you can't have it, man. Back along. Okay, so it says, on her next jump, the gymnast decides to reach a height above position B. So I just draw the basic thing out again. So this is A, B, your basic trampoline there, very accurate. Just like a hole somewhere. In terms of, describe and explain in terms of energy and work, the transformations that occur as she ascends from her lowest point A until she reaches a new position above B. So, we've got to talk about energy and work. So that tells us we've got to transfer, we've got to talk about energy transfers in terms of gravitational and kinetic. Obviously we're going to talk about height, changes in velocity, how that transfers to gravitational. So we need to incorporate that all into our answer. Now don't be scared when it says written communication. Don't think you can't put it in bullet points, because actually that's the best way. It's a 6-mark question. The best thing to do is put 6 bullet points and you read 6 points. And as long as you've written in English, you'd be okay with the English bit. If you write it in French, you're kind of stuffed because you haven't read the question properly. And if you're doing it in French, I kind of question if you can do A-level physics. Not because you're French, but I'm just saying, write French, you know. So, so for 5 or 6 marks, when you want to be aiming for, you need good to excellent. The information conveyed by the answer is clearly organised and logical. Basically what that means is the examiner can see where your points are. So you just need to be able to do it very clearly and concisely. So I think a couple of things you need to say. The elasticity is potential. So when it's here, there's a lot of energy built up in the spring. You need to say the elastic energy, so elastic potential. I just put elastic, converts to kinetic energy, and then the kinetic energy converts to gravitational energy, as she gains height. Obviously, you'd write it, instead of just arrows, you'd actually explain it in words, but I'm just doing it in short points as she gains height. The gym. Oh wait, actually, when you say here, the elastic is connected, just turn into kinetic. You can, because she wants to get higher above B. You can say she can bend her knees more. That's what it says in the mark scheme. Bend her knees more. Due to chemical energy. So your metabolic rate, for example. Sorry, should have stated that at the beginning. Never mind. So kinetic energy is she gains height. But some of this so that's 2 points at the beginning, is transferred to resistance forces. So we've got 4 points, 4 marks. Resistance. Sorry, let me just make sure I've got everything. Oh, God's sake, I don't like this. But obviously, if she wants to get higher than B, she must store at the beginning, store more energy in, store more elastic energy, or actually, I think a better way of putting it at the beginning is do more work. And this is in terms of the amount of energy she stores in getting to the height. So do more work is store more energy, and store more elastic energy. So when she jumps, more of the elastic energy is converted into kinetic, so she gains more GPA, so she can get higher distance above the trampoline before she stops, so higher than B, and obviously this would get higher marks. And just another thing you might want to talk about is the conservation of energy. So I'm not going to write it down actually, but you don't have to put it. One thing I would put is about, obviously, if you want to, because of the conservation of energy, all the energy she starts with must be ended within the world, because you can't conservation of energy states that energy cannot be created or destroyed, so it's transferred to the resistance forces or the gravitational potential from the kinetic, and the elastic is transferred to the kinetic, which is transferred to the gravitational and the resistance. So just to go over that one more time, if she wants to, right, the first thing you do is talk about the movement from A to B in terms of forces. So the elastic energy is transferred to kinetic, the kinetic is transferred to gravitational, so she gains height, because mg times delta h is GPA, and more height equals more GPA, so that's how you convert kinetic to GPA. Some of this is transferred to resistance forces, so you talked about the forces there. Now you need to talk about, well, if she wanted to increase her height, she'd bend her knees more, so she can need more chemical energy and more elastic energy. And a final overall statement you would put about the conservation of energy, as we said. So there are your main points, and that's question 4 wrapped up in a nutshell.